And now I would like to welcome to the stage Philipp Kandal from Skobbler, who will talk to us about one of the hot issues in tech nowadays, which is big data, but big data on a small budget. So let's have him here. Let's give him a round of applause.
Thank you. Thank you very much. Okay, so I'm going to talk to you a bit about big data, but let me give you a quick chance to introduce who I am and what do I have to do with that subject. So my background is I'm a CTO and a co-founder of a company who's doing navigation systems. So we are a German-Romanian company. Actually, 90% of our team is located in Cluj-Napoca, with about like 70 people there. We have a small office in Berlin with 10 people, and I do spend like half of my time here. And so basically, what we do is we try to deliver the user something comparable to Google Maps navigation. And I want to tell you why big data for me personally is extremely crucial to product development. You know, back 5 years when we started the company and started to develop product development was happening in this way. The founders get together in the evening, share a glass of nice red wine, get some inspiration, draw how a product concept should look like. We'll try to put it on the market and see if it works, if it doesn't work. That's how traditionally it works. And traditionally, the first result for our first products was pretty horrible. It was a pretty miserable failure. And we didn't really know why. Because we thought we had some really nice inspiration, some really nice red wine, and we could build and plan and design some really awesome projects. But we didn't know why it didn't work out that well. So we thought, well, maybe it's time to take a more metrics-driven approach, to more log what our users are actually doing with our products. And then we came to a way that we found that actually the combination of agile software development, to have a release every few weeks in the hands of your customers, log exactly what they're doing, and based on that, make improvements to your product, is the killer way to develop products. You will still fail at times, but you will exactly know why and you can improve. So that's the whole idea behind big data. So what we do now is we log the positions from all of our users when they're driving. And we have more than 100 billion rows of data in our database. We have close to 20 terabytes of data, growing at tens of gigabytes every day. And with this use of big data, we increased our revenue significantly, we made our products better, and we'll soon conquer the world, I hope, the last part. So that's basically why, for me, it's a subject that's extremely important. But let me give you a few more examples of why it's important for other people. So the Harvard Business Review said that big data scientists is the sexiest job in the world. Because that's basically where the future is. The future is not of people who have like some things like some talk with God and get like experience from there. The big thing is about people who have an idea on how you can measure and improve results. That's how Amazon, Google, Facebook, how they develop their products. And the thing which I'm talking today about is that you can do that on a small budget too. You don't need to have a 10 million or 100 million euro data center to do that. You can do that for a few €100 and massively benefit. If you look at the first election campaign from Obama, he in large parts won because he used big data and he knew which voters he can target to vote for him. And that was a big data behind it. I mean, some of the most famous big data scientists come from the political world. The next thing is like a lot of world-class athletes. If you look at tennis matches, at soccer matches, all of that is exactly analyzed and they know exactly which player plays how well and so on. And the big companies all use it. So if you either want to be sexy, if you want to be a president, a top-class athlete, or very rich, then you should definitely care about this very, very much. So I think it's a very important subject. So let me iterate a bit on what are things that are really great with big data. So big data is generally a really, really good tool if you want to optimize things. So if you want to measure what your users are using in your product, and if you want to optimize their behavior, that they click more, that they buy more, whatever behavior you want to. Big data is really awesome for A/B testing. A lot of times at big companies, product development doesn't happen that one guy says, this is, I think, I know how it works, we'll do that. How it works is that one guy says, I believe this will work, the other guy said this will work, and then you put both ideas to practice and let them fight against each other, and the best idea wins. So big data is in a lot of ways a very democratic ways to find decisions in companies, because now also a small developer who before could never make a decision about the product can make a decision, test it, and if he gets proven by the numbers right, then his decision will be in production for millions of people. So that's very empowering. You can use it for improving monetization as well, or to check the adoption of new features. So that is all very, very important use cases where I think no startup should live without big data these days. I think that's very, very important. But let me be honest, there's also some cases where big data doesn't make sense. And mostly it doesn't make sense when you do not know what you're optimizing for. If I want to invent something groundbreaking, which I don't know if people want to use it, and in the beginning days, I might need some radical innovation. Big data is good if I have some iterative approaches and can pitch them next to each other and check them out. If I want to build a completely new product, how people interact or something like that, in the beginning, until I figured the product out, I might not be able to test it. So then big data for these big innovations might not be the first best thing. In the beginning, once you have a product, you can test it out, then it's awesome. But for making this big leap, it might not be the best. And then big data in general, of course, only works if you have big user numbers. If you have 5 users and try to get statistics out of them, that's completely nonsense. So in order to have big data working, you need to drive users to your product. And you can do that in easy ways, like paying for an AdWords campaign. But if you don't have like at least 1,000 people in a test, then it's not going to be very meaningful. So let me go to a bit more practical part. So big data, as I said, at Skobbler, and how I see it, is a crucial part of the development process. So a lot of people think like you do that once and then it's done, but it's not really how it works. So we have 5 steps in our process that are always very, very important. So the first step is to log all the data, to make sure that you have everything that you need. The second step is to process and enrich it. The third one is to analyze it. The fourth one is to take improvements out of it. And the fifth step is to check if these improvements work, evaluate them, test them, and then go back to step 1. And ideally, if you have a good big data environment, whenever you run an agile sprint, so every few weeks when you deploy a product, you have that cycle working once completely. So ideally, big data is a continuous process of your development technology and the methodologies which you use. So let me go a bit into technical details because I know it's a tech talk, so I try to make it accessible for everybody. But let me also tell you a bit what's the tools that you need to look up. And I cannot go into much details about how they work, but in general, the big message behind them is that big data is really accessible because none of these tools cost you $1 in license fees. So everything that you can use will be completely free. So if you look at the steps which I presented earlier, you can do logging in the database called MongoDB, which is a NoSQL database, which is a very big innovation in recent years. If you want to do it in memory, you can do it in VaultDB, so that's awesome, or a cluster of Cassandra machines. So all of that really free technologies to use it and to store your data. And storage is very cheap. So that's like the good first news. For storing data, basically, you don't need to make virtually any investments. And for processing, this was in the past one of the biggest innovations that made Google big, is they had a protocol, an internal protocol to analyze this data. And since a few years, there were some open source guys who basically copied the distributed processing that Google had. Historically, you had to buy very big mainframes, $1 million IBM machine or something like that. But then these guys at Google came and said, let's buy $1,000 machines, and we can be 100 times faster than $1 million IBM machine. And that was basically the intellectual groundage for technologies like Hadoop, HBase, which are the more traditional big data processing tools. There's more modern ones like a framework called Storm, which Twitter uses to process all the tweets in real time. And it's completely free. Twitter invested millions of dollars in building that, and they're giving it in your hands for free. Or LinkedIn has a framework called Zamza, which they use to analyze who you should get to know. So anytime when you log onto LinkedIn or Twitter, you're in connection with big data without knowing it, and they give you the tools for free to use them as well. And then there's also awesome stuff. So what I told you earlier, still there's a human involved in making the decisions on how to improve. So, but what you can talk about big data, and a lot of times you can even take this human out. You can even take a machine to make the decision what is better. Because if you give him a goal and saying, I want my customers to buy a pair of shoes, that's the goal, that's the solution A, that's product solution B, and just at the end, when you fight product solution A against B, just make the decision which of the 2 solutions will go into production after you test each to 1,000 customers, and then it automatically discards it. So you can do a lot of things. That was a very simple example, but you can do much more with machine learning. So there's an awesome framework called Mahout for using it for these kind of things. So the important thing is, like, as I said, the whole talk is about it. I'm not talking about companies with millions or tens of millions in funding. I'm talking about anybody. So the thing is, you can do that really, really cheap. So how do you do that? Well, first of all, the most important thing is that the cheapest thing is to process this data offline. Because a lot of times you do not need to have the results immediately. You don't need to have the result 1 second after the customer leaves your website. Often it's absolutely fine to know, like, deploy a feature, test it for a day, and then check out if it's worth to keep it or not. So that's absolutely fine. So if you process it offline and not in like the expensive Amazon cloud, this is really nice. So I'll give you an example. We bought just recently one of our big data servers, and we have a lot, so that was like 10,000 euros or something like that. And we made a comparison of what it costs us to run the same performance on Amazon. And for 1 year, running the same performance at Amazon costs $500,000. It's almost 50 times as much. So it's really like a very, very significant performance difference, because the Amazon machines are very, very expensive, and they're also, due to virtualized nature, much, much slower. And also, as I said, use open and free software. You don't need to buy an Oracle database or any IBM stuff. Just use what I showed you. That's very important. And the key thing is always, there's 3 types of big data. So there's basically when you need real-time results. So imagine that a customer comes to your site and sees one ad. And you not need to show him which ad he should see. Should he see an ad for shoe pair A or shoe pair B? So then you need to have a real-time analysis and say, this customer should get A. So then you need to have real-time big data analysis. So then you need to really buy the fancy stuff. You need to have the in-memory databases. It's still affordable, but it's much more expensive than the other things. So if you need to make a decision, let's say in 100 milliseconds, you need to have a lot of processing power available immediately in the data center. Sometimes you need like near-time results. So what Amazon is doing when they're recommending you products, like when they're like going to, this is your personal products, you visited 3, 4 products lately, so they just have like 5, or which people you should get to know in LinkedIn. So that's absolutely fine if you get the results like in 10, 15 seconds. But then there's also some stuff where you can know them much later. So think about like this Amazon feature, people who buy book A buy also book B. They do not update this list every 5 seconds because just a new customer buys a book. They update this maybe once an hour, maybe once a day. And that way they save a lot of money, because you can have 1 million people looking at the result and you only need to process it once. If you process it in real time, you might process it 1 million times. And that's very, very expensive. So look at when you can do real time, near time, and batch and store the result. So that's the key way to save money. Let me run you through the practical example of how the big data setup works. And I'll run you through twice. I'll run you through once in theoretical terms, and the second time on how the big data setup at Skobbler looks like and what we do with it. So that you have an idea that this is not theory I'm talking about, but it's practical stuff which is put to use. So the first step is to log as much data as possible. Because at the end, you can only answer a question from big data if you have also the information about it. So make sure that you define what is interesting for you. And think about the future, not only now. Do you want to know from which country your customers come from? Do you want to know which site referred them to you? Do you want to know which sites they clicked on? Do you want to know what browser version they use? So there's tons of stuff. So define all the interesting data, upload it, store it, and keep it there for the beginning. You might not use everything in the beginning, but often it's interesting to track it historically, how usage of your site or your app develop. And that's the first step. The second step is to run it through your processing chain. So in our case, this is Hadoop and HBase, and make sure that it gets moved to another environment. As I said, it depends on if you run it real time, near time, or in batch mode, but just move it there and enhance it with all the data. So one of the key tricks is also, at this step, to get more information than you have from your visitors. If they log in with Facebook, link their social data to it in the processing part. Link data from like their IP address, reverse IP geocode their address and find where they're from which country. It might be very important. Maybe you find out that some customers from Germany buy this, some customers from France buy a totally different thing. So it's very, very important here to enhance the data with all the information that you have. And then comes where the really interesting part comes from. Analyze the data and find meaningful results from that. Because data basically is a big, big ocean, and without knowing what to do with it, the results are really meaningless. So first of all, define what's your key performance indicator. If you're an e-commerce site, maybe your key performance indicators might be customers buying, customers registering, customers looking at products and so on. So that might be what you're looking at. And then you can see, okay, this is the kind of performance metrics that you want to improve. So you want that every customer who gets to your site does as much as possible on your site and gives you as much money as possible. So when you know that, then the next job is to cluster the data. So you need to figure out what does represent a good customer and what is a bad customer. Not because you want to know about this person, but you want to know which customers at the end are bringing you a lot of money and how you can encourage more of these people and more of this behavior. So make sure that you know either by geography, time, site they're coming from, features that you provided them at this time, and then or look at where you're losing your customers. At which step are the customers signing out of your site and not buying? So if you can figure all of these things out, then you can compare it against the reference set. So if you do develop a new feature, deploy it in 2 weeks, and then you see that suddenly less people buy, and then you can check with this comparison why, where they're going out of the site. So you can ask questions, and the great thing is about big data, it's not only about developers, it's a mix about developers, product managers, business people who can have all access to this data and they can ask questions. So they're not like some people who get some inspiration or something like that, but you really ask a question and you can get a definitive answer, and that's very empowering. And then the next step is this continuous tweaking. You improve it. You can have a theory. Say, hey, what if we remove these features? I mean, like Bobby said earlier, when they removed 40% of their game, and they were very confident if it works. So if you do a change like that, it's very crucial that you measure afterwards if it works or not. So you can do these changes, tweak, and measure what's the result. And everybody can make a theory. I think that's very important. Everybody in your company can have a theory what to do to improve it, and you might not put it in front of all of your customers, but in a certain set in an A/B test. And if the person is right with the theory, it gets deployed to everybody. If not, it gets thrown away. Very, very simple. It takes a lot of argumentation out of the company. And then at the end, you evaluate. You see what happens. Are the results with your improvement better? Great. Keep them and keep going in that way. Are the results revert to what you have last week and try again. And this is a continuous process. And if you run it every 4 weeks or so, and you can run this whole process 12 times a year. Or if you do it every 2 weeks, you can maybe even run it 24 times a year. So this is pretty amazing. So this is really where you should go to. So let me explain in practical terms how we do that at Skobbler. So at Skobbler, first of all, we log practically everything our users do. We're a German company who has to be aware of privacy, so everybody can turn this off, unfortunately. But at the end, basically, most of the people keep it on and send us their data. So they send us everything from what version they used, what kind of routing profile they used, devices, all of their positions, anonymous, obviously not with their user ID, but just the drive ID, which country they're coming from. They have the ability after every route to give it a quality rating and tell us how their experience was. So we have also a qualitative feedback after every navigation. And of course, we know if they reached their destination or not. I mean, a navigation is a very simple KPI. If you reach your destination, usually your experience was quite okay. If you don't reach your destination, then we did something wrong. So in the next step, we process it. We combine it on a per drive session. We combine it on a per segment session. So for street segments, we know exactly how many people are driving on a certain street, what speed they're driving, and we identify some key behaviors. So for example, anything that's bad. If you do not follow our route, then obviously something is wrong. So this is kind of the things where we know that we did bad. And that's an example of how it looks like Berlin looks like in our data for 5 minutes interval. So you can see this is our people driving around, and you can see pretty much the street network. So we can say in Berlin with this, you could, for example, use this to generate traffic jam data. So we have in 5 minutes, we have basically somebody going over all parts of Berlin, and you can generate this. So this is really, really useful. This is with the Storm framework, and that's an example for near-time processing. We don't need to get the results in 100 milliseconds, but maybe traffic jam will not be relevant 5 minutes later. So this is one of those examples. This is another example of historic driving patterns processed with Hadoop and HBase. So we have can exactly say in which areas our customers are. And as you can see, if you would zoom out a bit more, you can see that a majority of our customers are actually in Germany. And exactly in the areas in Germany where there's a lot. So this is just part of our data, but you can see here is I don't know, a visualization of 13 billion points from our users. So it's 5 to 10% of our total data. So this is really helpful also. If you visualize the data, it's much better to use it than when you just basically have some Excel sheets or something like that. Whenever you can visualize it in your site, make a heat map of where people click. For us, make a heat map where people drive. So this visualization stuff is really, really powerful. And then basically we look at analyzing it. So we look at basically, how did the user rate their experience from 1 to 5 stars? And if they rated bad, did we do any changes that resulted in that? We look at how many reroutings they had, so how many times they didn't follow the route. We look at how much time we told them they need to the destination and how much time they actually did need. And then basically, we cluster it using geography, routing algorithms, and so on. And then we have a lot of insight. And then we know exactly, I can tell you exactly, for example, that the last time we measured it, our routing quality by our customers in Germany was evaluated to, I think, 4.4 stars or something like that. So it's good, but it's not perfect. So we're still working on that. And we can tell you anytime that we evaluate it and make changes, over time it goes constantly up. So then we improve it. We do it partially automatically. So we take all the drive data and optimize our arrival times, because we exactly know in which areas we evaluated good, in which areas we calculated badly. And then we go and make some country-specific tweaking. So we say like, okay, in Germany, in the Autobahn, you can go obviously much faster than the Autobahn in Romania. So maybe you need to have a different speed profile there. So like very simple things there, but also much more complex things. Maybe in some cities you need longer traffic lights than in others and so on. So we can measure it, test it, if our theory is correct, and then put it to action. So, and then basically we deploy all these changes, and then we go back through the whole cycle. And as I said, so we have seen with our products that we could massively improve the user satisfaction with that, and we could provide much better routing profiles, because we have a routing profile that uses big data and a reference set that's just based on the map data. And I can tell you that the one based on big data gets significantly better ratings by the users. So we know that we have, at least from our 5 million users, we've definitely gained a lot of them due to the fact that we use big data. And we don't spend a lot of money with it. We really do it on a startup budget. We don't have like a big data center with hundreds of machines. We're running it on relatively cheap hardware, and maybe on total on our big data hardware we spent maybe 25,000 euros, and we have fairly big data sets. And we've gained probably millions with it. So I think that's really the important lesson that everybody can learn, that it's really possible. So I think the summary is that basically any startup today which is not using big data is really wasting their potential, because if you want to beat Google or Facebook, then you should use the tools that they use. Because no matter how smart you think you are, you're not as smart as data. I'm sorry to tell you, but data is much smarter than you, because it's objective and you're very subjective. And if you take data and a smart human mind together, then that's the killer solution to build killer products. And that's how you should do it. So the formula is very, very simple. Log the data, process it, analyze it, improve, evaluate, and then start from step once over again and run that through 100 times, and you'll have a fantastic product and be very successful. Thank you very much.
Thank you so much. That was a great talk. And now we're ready to take some questions.
Hi, this is Chris from Bosch again. You mentioned that the tools and the technology is free, open source, all that kind of stuff. How much effort do you find it takes to install, configure, maintain all this underlying technology? Is that also pretty simple, or do you have a team of data scientists or expert database engineers that can do that for you?
That's a very fair question. Actually, when we started our effort 3 years ago, it was really fairly complex. But luckily, since this got much more mainstream, actually now it's fairly simple. I mean, now we can have a junior developer setting it up. I mean, of course, you need to learn about it and be a bit more senior. But 3 years ago, it was really complex. Nowadays, I would say you can have it running in a base setup in maybe 2 weeks if you have a fairly good developer without knowledge about that. You can have your first thing running to look at the data, and then you will learn over time. So I think it's possible within a few weeks to get it going. So there's a lot of great documentation online now.
Awesome. Any other questions?
There, somebody? Oh, yeah.
A mic is coming to you.
Thank you. Hi, I'm Julia from Avangate. I have one simple question. How do you evangelize inside a company the configuration of such tools?
Well, actually, for me, it was a different question. We have a great engineering team, so I always rather don't need to encourage them to do these things. I need to stop them from doing more experiments. So actually, it wasn't me who evangelized it. I have a fantastic engineering team who came to me saying, this is what we want to do. We think it will be much better. I said, I need to buy hardware again. But okay, you're usually right, so I'll let them do it.
If you would have to make some recommendations, assuming that, let's say, you wouldn't have had
So one thing that we do is
the availability to install this.
So one thing that we do is we have a learning Friday, one Friday a month, where people just play with crazy technologies. And that's usually in our company how these kind of things come to happen. I mean, usually like some of the engineers, without me allowing it, like hack some of this stuff together and then shows me that's what we want to do. And therefore we have a formal learning Friday where people can do these things and where they have to like pitch, okay, what's the best way to do it? And also like sometimes we put just some people on leave like to like put people on new technologies. So, I mean, what we believe is that a lot of times this innovation, you need to give people a bit of time to work on that. So I would encourage every company to put like some weeks for crazy stuff on the side, and sometimes it gives good results, sometimes it doesn't give anything. I mean, we did do anything from buy people drones to see if they can do video mapping or some smartwatches. So what my finding is if you have great engineers and give them some time allocated to that, if you don't put them under constant release stress, but to give them some time to check this kind of things out, you usually get like some results. And otherwise, what I would recommend is always checking when you can basically see some potential in this, just build a small prototype. Just like put a team on it for 2 or 4 weeks and build it really scrappy. Don't come with big visions and implement them, but try a small step, see if it works. If it works, continue. If not, then not. So I mean, this is all about the agile philosophy, which I think helps a lot in trying these kind of new things out. And if they work, continue. If not, kill them.
Very cool. One last question.
Hi, my name is Dimiter. Very good stuff I found out today. Thanks a lot. I'd like to ask, do you use any statistical software, example R, stuff like that, to just cluster the data or whatever, or anything outside the programming stuff? Do you use like specifically statistical software? Do you have statisticians? Who makes the connections between the data? Because you have the big data, but then you have to have a bright mind to analyze it.
So we have a few PhDs in our company who take care about the statistical analysis. But we do not use any dedicated statistical tools, but I think it would be a really, really smart thing to do. At the moment, what we use mostly is like really this kind of visualization. So we use usually like inbuilt capabilities of the tool, which I showed you of Storm and something like that, to visualize it. So the most powerful analysis tool which we have is visualization. Because you can usually, like if you put the data on the map and we build some tools that the people can say, put me the data on the map, how people are driving on a Monday morning at 9 o'clock in Berlin, how they're driving Monday afternoon at 3 o'clock. And if you can visualize this, then usually you can understand it very well. So it's much better than using a spreadsheet or anything. I think this depends on the use case. But for me, I'm a huge fan of visualization. Thank you.
Great. Thank you. That was a great talk. A lot of information condensed.